So this question, everyone, is like a model. This represents a formula for solving for something. It could be an area. But don't worry about that. You're trying to basically isolate a letter. The letter you're trying to isolate is the lowercase b. Why is this question tricky? Well, you have a capital A and a lowercase a that sometimes messes with students. But just remember, treat them differently. They're different beasts. And the parentheses scare people. So I tell you, start tearing it apart one piece at a time. Do you agree? The 1/2 is multiplying by this. So how can I get the b? How can I get that b 3? Well, that 1/2 needs to go away. How do you remove a 1/2? Well, you multiply it by its multiplicative inverse, 2. So we're going to multiply 2 times both sides. Well, the 2 times 1/2, I hope you see that quickly, that's going to go away. That b I'm going to keep black, but this cancels. You got rid of a fraction. Was that similar to a problem we did earlier? Get rid of the fractions too? So now you have 2 times a on the left side, and on the other side, it's simply h times a plus b. Now, I saw people multiply this through or distribute it through, and that's fine. You'll take an extra step, but that's not a big whoop. What I'd recommend now, do you agree? I still need to free the b. Let's get rid of the h that's being multiplied. So could I divide both sides by h? Certainly. Whoop-ah! Of course it's gone. And you're left with 2a, 2 capital A over h, is equal to, and watch what happens next. I just dropped the parentheses. Can you do that? Absolutely, because now there's nothing being multiplied by it. Now b seems to be getting closer to being set free and being isolated, solving for the variable that you're trying. How can I get b alone? Let's subtract lowercase a, and what I do to the right side, I better do to the left side. You'll finally get the answer we're seeking. It looks strange, but you can program this in Microsoft Excel to calculate a variable of your interest. But there is b equals an expression, and that's what you got to do. So good job.